So this is our revision of the March exam, which we had for our mathematics N4. So we are going to consider the full paper that we wrote so that we can be able to see where we had the mistakes or some other methods that you could actually have used. Maybe used another method, which was fine. We just want to see how are we supposed to attempt these typical questions. And I'm very glad that most of us, from the response that I'm getting, it shows that we actually did well. That is actually perfect. I'm not gonna talk about the names, but from the feedback that I've seen, it was actually perfect. So I just hope for those who are writing in August, you're going to do the same thing. I was actually quite surprised to see even 100% in mathematics and for 100% from a student. That's actually perfect. So these revisions, they are actually important to some extent. So let me know about the areas at least that we can work on, revise on, so that it can help us in our preparations in any other subject of our N4 as we are moving on. But anyways, let us quickly rush through our question paper and see how you're supposed to have these questions. 1.1 on question 1, you were given to draw a neat graph. All right, so you're supposed to have your graph there. You draw your graph, which is perfect. A neat graph. So in this case, I'm just going to have a sketch of how your graph was going to look like at the end. So the first thing is, what type of the function that you are given? That is 9x squared plus 4y squared is equal to 36. What type of the function is it? This is an ellipse. I said, if you were given, let's say, a condition of 9x squared plus 9y squared is equal to 36. This is a circle. If these two are the same, that will become a circle because you divide by 9, by 9, by 9 throughout. I want you to see what is going to happen at the end. That's x squared plus y squared, which is equal to a 4. As we can see, this is the normal format of a circle that you are used to. If these numbers were the same, it's a circle. But these two numbers are different. That's a 9, that's a 4. So this one, it is an ellipse. So it just says similar properties, just like a circle, remember, from your N3, all right? So in order for you to have this, what is important for you is to determine the intercepts, which is the x-intercept and also the y-intercept. So we know that for the x-intercepts, what is the condition for the x-intercepts? Y is supposed to be equal to 0. Why am I saying intercepts? There are going to be two values. When y is equal to 0, it means this part is eliminated. We do not have this. We are going to remain with 9x squared equal to 36. So divide by 9 both sides. What are you going to have? X squared is equal to a 4. So to find the x values, introducing the square root to remove the square, that means we've got plus or minus 2. That is two possible values of x. All right. On the other part, we can consider the y-intercepts. That is, for the y-intercept, what is the condition this time? X must be equal to 0. It means we have eliminated the part of x. If x is equal to 0, we no longer have this part. So we are having 4y squared, which is equal to 36. Find the y values, divide by 4 by 4. That means y squared is equal to 9. So to determine y, you're going to introduce the square root. That is a plus or minus for the square root. So as we can see, we are having two possible values for x plus or minus 2, plus or minus 3. This is two possible values and they are different. This is 2, this is 3. If it was a circle, you're going to have same answers. Maybe your x is plus or minus 2. Y also is going to be plus or minus 2. This is a circle when it is of this nature, when the value of x and the value of y are the same. That is a circle. But if you check here, these values are different. All right, so like I said here, I'm just going to have a sketch. So you were going to have your x and y intercepts. All right, then what was important is the x value at 2 and at minus 2, the y value at 3, and another y value at what? At minus 3. So these are the points that you mark: minus 2 and positive 2 for x. For y, there's a positive 3 and a minus 3. So with these, you can even join to have your ellipse. So it is not a circle. No, this is not a circle. All right, so this is, guys, just a sketch, okay? But you're supposed to have something that is accurate to this part that I am indicating here. Yours is supposed to be accurate and very neat. That's why we are saying we're given draw a neat graph. All right, then the other part of the question, it was to draw the graph of y is equal to the ln of x, that is a log. Remember, the ln is the logarithm in the base of e. So if you know your graphs, from your, remember your N3, if you know your graphs, you are given to draw the graph of y is equal to the log of x in the base of e. That is the ln. This is the graph of ln. Y is equal to the ln of x. Ln x means the log of x in the base of e. So if you know how to draw the graph of a log, then you are done. You just have to draw this function. But in this case, with the values of x, we know that a log cannot operate with the x being at 0. The log cannot operate. We cannot have our x being at 0. We can have any other value besides a 0. We cannot have our log at 0. Meaning to say the ln also is not at 0. We cannot have negative values, -1, it's impossible. So if you were to use a table of values, maybe you are someone who was focused with the table of values there, how are you going to draw this graph? Y is equal to the ln of x. So you can even obtain your x values, since x cannot be 0 or a negative. You can talk of any positive value, 0, 1, 1, 2, 3, 4, and so on and so on and so on. That is the idea there. If you are given a condition where you are to draw, you obtain your y values, you are going to see that the y values will be increasing exponentially, like this is what you're going to have at the end. The y values will be increasing exponentially, increasing in the positive. Knowing that a logarithm at a point where we have 1, the logarithm of 1 is equal to 0. At x is equal to 0, we do not have anything there. Negative values we do not have. It cannot be a negative. So that is how your graph was going to be like at the end. So I just hope you do understand from the sketch that I'm having there how you're going to have your graph at the end. 1.3 What is the domain of the graph y is equal to the ln of x? The ln of x, I talked about this, it cannot operate at 0. That's why here we can have 0, 1, whatever that you have. But at 0, I talked like we cannot have anything from 0 going this side. That alone helps us to determine the domain, because the domain, these are the operating values of x. Our x is operating this side. So on this side of the graph, from a value that is just a slight, as long as it is just bigger than a 0, it is not supposed to be a 0. So in actual sense, x is equal to 0 is actually an asymptote. Our values cannot be at this. So meaning to say x must be greater than 0, and x being an element of the real numbers. X must be bigger than 0 for this function to operate. That is the idea there. So this is what they will be asking you in your final examination, just like that. Draw the graph of y is equal to minus the square root of 25 minus x squared. What type of a function is this that we are referring to? That is the question. We are given y is equal to minus the square root of 25 minus x squared. Okay. We do understand if we are given something like this, x squared plus y squared is equal to 25. We do understand something of this nature. That's a circle when it is like this. Okay, let's say I want to make y the subject. It is supposed to be what? Y squared is equal to 25 minus x squared. Introducing the square root, meaning to say y is equal to the square root of this, and knowing that the square root of any number is a plus or minus. That is what you are supposed to actually have. This was a circle here. Having plus or minus, it's still a circle because we just made y the subject. Okay, guys, it's just like we are given y is equal to 2x plus 1. What type of a function is this? That's a linear function, a straight line. Okay, let's make x the subject. Y minus 1 over 2 is equal to x. What type of a function is this? It's still a linear function. Nothing has changed. Still a linear function. If you input the values of x and the values of, we are going to have a linear function. We just made x the subject. It's just like we are given y is equal to x. Then x is equal to y. Nothing. We just made x the subject or y the subject. We made y the subject. Having plus or minus, it still means this is a circle. We are still having a circle there. But now on this question, they are not having the plus or minus. They are limiting us to a certain sign, a minus. Why are we limited now? That means it is no longer a circle. It is now a half circle. So when you are to draw this, you are supposed to obtain a half circle. It's no longer a full circle. Even if it was like this, maybe, remember, it was supposed to be plus or minus. So they can limit you to a plus. They can limit you to a minus. They can even give you like this. When it is limited to a certain sign, it is now a half circle. So in this case, it was a negative, meaning to say the y value is limited only to a minus. The y value, it is limited. So if you are to find the y-intercept in this case, where x is equal to 0, you are limited to a condition where y is only a negative of this square root. So that's 25 minus, remember, x is 0 and 0 squared is just a 0 there. And the square root of 25 is 5. So y is equal to minus 5. It's no longer plus or minus 5. No. Y is limited. Remember, you're supposed to obtain two possible values. Y is equal to plus or minus 5. But now it is limited. But X is not limited because take note, if you are to find the x-intercept, what is the condition of the x-intercept? I want you to see now for the x-intercept, Y is supposed to be equal to 0. If Y is equal to 0, you're going to have 0 is equal to minus the square root of 25 minus x squared. Whether you are to square, you are to divide by negative, whatever that you're going to do, this negative here, even if you divide by it, that will become a 0. There's nothing here. 0 divided by minus 1, that's a 0. Remember, you can divide. It's impossible for us to divide minus 1 divided by this one does not exist. So be careful. This one, it exists. 0 divided by 2, that's a 0. It exists, this one. So the negative is no longer there. There is no minus 0. There is no plus or minus 0. It's just a 0. So it is equal to the square root of 25 minus x squared. So x is not limited. As we are to determine the x values, you square to remove the square root. That is 0 is equal to 25 minus x squared transpose x squared. This side, it will be a positive since it was a negative on this side. Introducing the square root both sides, you're going to obtain that your x was going to be plus or minus 5. X is not limited. But knowing that this is a half circle, you do not have to go through all these. No. Guys, understanding that this is a half circle, you know that if y is supposed to be plus or minus 5, what is supposed to be x? X is supposed to be plus or minus. They are supposed to have same values. Only that x is not limited, so it will be plus or minus 5. So just knowing the y value, it is enough for you to know the x value. Without this calculation, it is not important. So here I'm just showing you how you're supposed to have it, but like I'm saying, it is not these stages that we have just showed now. There's all these calculation here, they are not even important. If you know that y is minus 5, that alone you can even know the x value to say, okay, if it is remember it's a circle, but a half circle, it is just the same properties of a circle. Same values to say this is a 5, this is a 5. So if you know this is minus 5, you know your x is plus or minus 5. Same if x was limited, because sometimes they will give you x being limited. X is equal to minus the square root of y squared minus 25. It's x this time which is limited. They can give you something like this. You calculate the x-intercept because x is limited to a minus, where y is equal to 0. All right, so this is supposed to be 25 minus, guys, so that it can make sense. 25 minus, I hope someone just saw that. It's supposed to be 25 minus y squared like this. You substitute the y value to be a 0. In this case, this will be square root of what? Square root of 25, which is 5. But x is equal to minus 5. In the same sense, by just knowing this, I do not need to go through this, make y this and that. I have to know that when I am to determine y, it is going to carry the same 5, but only that it is plus or minus. Y is not limited. What is limited, it is x to a minus. The x is supposed to be equal to a minus. So that's why I'm saying this working is not necessary. By just knowing the first value, the other one, you must automatically write it down. Okay, so this is how it can be like. So we are still on our question. All right, so like I said, this is a half circle. We know the x value and the y value. The x values actually, and the y value. The y value, we just have y being equal to what? A minus 5. So we are limited to y being a minus 5. So let's say we've got 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5, 1, 2, 3, 4, 5. So actually for negative, I mean for these positive values that we are indicating here, they are not even necessary because y is supposed to be at what? At minus 5. So y at -5, you mark a point, but x is at plus or -5. So at -5 and at +5. So if you were to join, you're going to see that this time you are going to obtain a half circle. All right. So guys, yours is supposed to be smooth and very neat than this. Okay. So you're going to obtain a half circle. It's no longer a complete circle like it was supposed to be because of a limited value that we were given for y. Remember, y was limited to a minus only, not a positive. But if it was plus or minus like this, it was going to be a circle. But we are limited only to a minus. Okay, so that was how you're supposed to have this at the end. So these are the typical questions actually that you be given. So it was 10 marks. Then question number 2, you were now given that is 2.1 given 4x. All right, so we are given 4x minus 2y is equal to this. Determine the value of x and y using the Cramer's rule. All right, so we are asked to use the Cramer's rule in that case. All right, so that's 2.1 given 4x minus, all right, 4x is equal to, that is 4x is equal to minus 2y plus 4. And another equation, it was 3y minus 2x is equal to 2. And you're asked to use the Cramer's rule. Remember, the Cramer's rule is all about the order, the x and y values equal to the constants. So we need to have that condition, the x to and y values to the one side of the equation. So transpose this minus 2y, it will be a positive. That's 4x plus 2y is equal to a 4. Okay, so the order first. Before you talk about anything, you must have the order first. Okay, so here we still it's the same thing. This is 3y minus 2x. Okay, so someone can just avoid working with a negative, guys. You can even avoid working with a negative on x, which is one and the same. How can you avoid working with a negative? You can act as if you are transposing this to the other side. So it will be 2x. You transpose 3y to the other side. So it will be minus 3y. You transpose the 2 to the other side. So it will be what? A minus 2. Guys, these two, they are equal. So I can just write as 2x minus 3y is equal to minus 2. I'm just avoiding working with a negative on what? On x on the first term. But you can even write with a negative. There is no effect, guys. There is no effect at all. Or you can even divide by a negative. Minus 2x plus 3y is equal to 2. Avoiding working this with a negative, you can divide negative, negative, negative like this. So this will be 2x minus 3y is equal to what? Minus 2. Nothing has changed. Nothing has changed. It's still the same equation as what we had before. Still the same. So you can even avoid that. So that's 2x minus 3y is equal to minus 2. So I want you to work out with the original one, that as it was. I want you to just work out with minus 2x plus 3y is equal to 2 and see if you're going to have the same answer. You just substitute the same way that we are going to do with this one, but use the original one. All right, so remember your Cramer's rule that x is supposed to be the determinant with respect to x over the determinant of constants. On the other hand, y is supposed to be the determinant of y over the determinant of the constants. So that means we need to determine these corresponding determinants of each. The determinant with respect to x, remember the concept, close the part of x. You close this part where we are having x, substitute with the constants. All right, so that means we are going to substitute for minus 2 in place of x. The part of y is going to remain as it is. You take the coefficients, that's 2 and minus 3. So we've got 2 minus 3. Okay, the determinant with respect to y, you do the same thing. Close the part of y, you replace with the constants. So meaning to say the x is going to remain as it is, that's 4 and 2. But the part of y, this one is the one that we have closed this time. It is closed. So you replace with the constants, which is 4 and minus 2. We also need the determinant for the constants, where the constants are not involved. This part of constants is closed, so there is nothing to be substituted. You just take the left-hand side as it is, maintaining the sign, that is 4, 2. This is 2 and minus 3. 2 minus 3. The coefficient there supposed to be maintaining the sign. So that is the idea there. Determine the determinant of each. Remember the determinant, the product of what is in the major diagonal minus the product of what is in this minor diagonal. So that is the concept that you're going to have. So the product of 4 and negative 3. Okay, so this is 4 and negative 3, like this. 4 times negative 3 minus the product of 2 and minus 2. So this will give you a minus 8. That's the determinant with respect to x. The same part on the determinant for the part of y, we're going to have the same thing, the determinant with respect to y. Considering what is in the major diagonal, there is 4 and minus 2. So that's 4 times minus 2 minus the product of these two. That's 4 times 2. Okay, so this was going to give us negative 16. So that's the determinant with respect to y. In the same manner, if you consider the part of the constants, that is the determinant for the constants, what is in the major diagonal, there is 4 and minus 3. So that is the product of 4 and minus 3 minus the product of these two, that is the remaining part of 2 and 2. So that was going to give us negative 16 again. So with these, we just have to substitute into our formula. Like I said, x, the determinant of x over the determinant of the constants. So the determinant of x and that of the constants, that's negative 16. And that was going to give us 1 over 2 or 0.5. Okay. Then for the y value, you're going to obtain that y is equal to this, the determinant of y, which is negative 16 over that of the constants, negative 16, and that was going to be a positive 1. So y is equal to 1. So that is how you could have calculated the x and y values, y and x. So trying to substitute, does it make sense at the end is important. When x is equal to 1 over 2, that is 4, times 1 over 2, is it equal to minus 2 times y when y is equal to 1? Okay, because we're given that y is 1. 4 times 1 over 2, that's a 2. That is equal to minus 2 plus 4, that is a 2. As we can see, the left-hand side is equal to the right-hand side. That is true. So you can also do the same, substitute the x and y values here and see if you're going to obtain a 2. That is to cross-check if your x values and y values are exactly the values that you're supposed to have. This is just to prove. Remember, you did not use substitution method. So meaning to say these values, they are not supposed to give us an answer which is somehow not exact. All right, 2.2. So this was 5 marks. All right, so this for 5 marks, it's worth it. I think, guys, we just have to revise these questions. They are becoming smoother every day. So let's revise as much questions as we can. 2.2, given this, 2.21, write and evaluate the minor of a negative 6. So this is the minor of a negative 6. Remember, the minor, what we need is to determine the determinant when you close the row and the column where the negative 6 is. This is where we have our negative 6. All right. So on the part where we are having our negative 6 there, we are going to close the row and also the column where this negative 6 is. So as you can see, we are remaining with this part. That is the minor of 6. The determinant of that is the minor of what? Of negative 6. So the minor of negative 6 was supposed to be equal to the determinant that you obtain if you close. So as you can see, we are remaining with 3, 6, 2, and 1. So that's 3, 6, 2, 1. So that's how you determine the minor. So again, this is the determinant, guys. As usual, the major diagonal, you multiply these two, that's 3 times 1 minus 6 times 2. So that was going to give us the minor of this part, which was going to be a -9. Okay, so that's a -9. So that is the minor of a -6. So the difference that we have now is when they send the cofactor. So this is the cofactor of -5. Okay, so this was actually a mistake. We do not have -5. This is a +5 here. Okay, that's a +5. So this was actually a mistake made. They wanted to say the cofactor of a +5, the cofactor of 5. Okay, that is the only 5 that we have. So I'm just going to use a cofactor of 5 so that you just understand how are you going to calculate that cofactor if it was the cofactor of 5. So the cofactor, remember, a cofactor is a signed minor. It is a signed minor, a minor that is being multiplied by the sign that corresponds. Remember, the matrices for the signs, plus, you start with a plus, follow a minus, a plus, and so on. So it's plus, minus, plus, minus, plus, minus, plus, minus, plus. In this order, remember, there are 3 elements. So it's supposed to be 3 signs, but you start with a plus, plus, minus, plus, minus, plus, minus, plus, minus, like that. So when the sign is the one that will affect, so meaning to say, when you're talking about the cofactor of 5, like I said, this is an error because we do not have -5 here. So the cofactor of 5, it is not the part, remember, we are saying a signed minor. So the first thing is to have the sign. The sign corresponding to 5, it's what? It's a plus. The sign corresponds. So if it was the cofactor of 1, the sign corresponding to 1, it's a minus. If it was the cofactor of 2, the sign corresponding to 2, it's a plus. So that is the idea. This is a 5, so the sign there is it's a plus. So you have to show that this is the cofactor concept. Whether you know that it's a plus and a plus does not affect anything, but just to say it's a cofactor, this is the indication of a cofactor. If it was the cofactor of 1, you are going to start with a sign minus. The cofactor of 2 minus. You start with the sign because you're saying it's a signed minor. So the first thing is the sign. Then you determine the minor, the signed minor. So we need the minor now. The minor of what? Of that same 5. Remember how you determine the minor. You are going to close where this 5 is, close the column, close the row. What are you remaining with? You are remaining with 4, 2, 3, 6. The same way that you just calculated the minor, but only that it is affected by a sign. So this one, because of a plus, you do not see the effect. But if it was a minus, it was going to actually affect your answer. So you determine the cofactor as usual. I mean, the minor as usual. Remember the determinant concept. Multiply these numbers. The product of these, that is 4 times 6 minus what is remaining, 2 and what? 2 and 3. So this is going to give us a plus. The answer that you're supposed to obtain was 18. So the cofactor is plus 18. So that is the idea there. So you can even just leave it like that as an 18 or plus 18 like that. So minus 5 is not part of our this determinant, the matrix that you're given here. You are supposed to be given an element inside there, okay? So that was supposed to be our question. Then question 2.3, if you're to consider this one, it was just an awkward question. It's just given the C's, you're given the angle. This is just one and the same presentation. There you are given pi over 30. I don't know. They actually wanted to ask it this way, or it was just some or a mistake in printing or typing there. I don't know. I mean, in typing. So anyways, let's see. Simplify 3 cis 60 degrees. Remember, the cis is just the angle, like just like what we're given, this angle here. So it's just like 3 angle of 60 degrees times 2. The angle that we are given, it's pi over 30. Remember, pi is in radians, but to degrees, it is 180 degrees. So meaning to say, if it is pi over 3, it's also 180 over 3. And 180 over 3 is going to give us what? That is 30, sorry, pi over 30 degrees. So it is going over 30 degrees, and that is going to be a 6. Just a 6, not just like that, 6. So this is pi in radians, guys. Pi in radians. So this actually it did not actually make the sense the way that they asked it. Okay, then this is 6, the angle of 50 degrees. Okay, so according to what you're given, this is how you're just going to answer it. But guys, let us just hope for the best in the coming exams. All right, remember, okay, this color here, it's actually affecting even my eyes. I don't know. It's the paper, the way it is dark or what. So there, remember the concept. If you are working with the polar form, the product, you multiply the numbers, the angles you add. So you're going to multiply the numbers 3 times 2. That is R angle theta. If you're given R1, theta 1 times R2, theta 2. The product is going to be R1 times R2. The angles you add, theta 1 plus theta 2. So meaning to say you're going to add, multiply 3 times 2, which is 6. Then the angles you add 60 plus 6, which was going to be 66 degrees. Divided to 6, an angle of 50 degrees. It's a division. So in division, how are you going to divide? If it was given as R1 angle theta 1 over R2 angle theta 2, you divide the numbers together, that is R1 over R2, but the angles you subtract, theta 1 minus theta 2. So you're going to divide the numbers, that is going to give us 1. Then the angles you subtract, 66 minus 50 degrees, that was going to give us 16 degrees. This is in polar form. But the question is, we are supposed to have this in a rectangular form. So how am I going to convert R angle theta to a rectangular form? Remember, this is R cos theta plus RJ sine theta. So meaning to say our R is 1, then this is our theta. So that was going to be 1 cos theta, which is our theta, 16 degrees, plus 1J sine 16 degrees. The part of the angle is affected with cos, but on a sine, you use a J. You can even leave it like this, or you can have it as a decimal. 1 times cos 16, that's 0.961 plus J sine 16 is 0.276. So this is the rectangular form in rectangular form. So actually, that is what you're given. There are 4 marks for that. So I don't know, these guys, I think we need to revise our question papers, guys, because I'm just seeing a repetition. Like, I'm seeing a repetition. I don't know if you're seeing the same thing. 2.4, simplify as far as possible. 3 marks. Okay, that's 2.4. Let me just try to write aside. That paper is just, I don't know, how did we scan this? J to the exponent of 3 plus J to the exponent of 4, everything over J squared minus j to the exponent of 5. Simplify. This type of equation is in your hands. You simplify the way that you actually want. Let's say I want to consider the simplification of these j to the exponent. Remember, you can be given a question that can be simplified just to simplify j to the exponent of 4. Remember, there are questions like that, where you'll be given simplify j to the exponent of 22, j to the exponent, if you still remember those questions. So what if we simplify first these j that we are not understanding in simplest form? J to the exponent of 3. Remember, in simplest form, we are supposed to write in terms of j squared, because we do understand that j squared is equal to 1. We do understand that j squared is minus 1, So whenever you are given a j squared, you are having a minus 1. So, all right. How can we express this? There is j to the exponent of 3. This is same as j squared times a j. This is to the exponent of 1. 2 plus 1, that's a 3. Where j squared is minus 1. So it means we've got minus 1 times j, which is minus j. That is j to the exponent of 3. We can write this in simplest form. We can write this in simplest form. So all this is supposed to be presented. You're supposed to show this. All this working, you're supposed to show it aside. So instead of you working with the j to the exponent of 3, work with something that you do understand. So that is a minus j. J to the exponent of 4, how can we express this? J to the exponent of 4 is same as j squared times j squared, which is simply j squared squared. 2 times 2, that's a 4. Where we understand that j squared is minus 1. So it's minus 1 squared. And minus 1 squared is what? Is 1. That's a positive 1. So instead, this was just supposed to be minus j plus 1 like this. Something that we are used to. J squared, remember j squared is minus 1. So that's minus 1. Then we move on to minus j to the exponent of a 5. In the same manner, j to the exponent of 5, it is same as, remember, we got j to the exponent of 4. So it is same as j to the exponent of 4 times a j. Is it different? Just one and the same, because if you add 4 plus 1, that's a 5. We know the value of j to the exponent of 4, it's a 1. So that's 1 times j, and 1 times j is what? That's a j. So in place of j to the exponent of 5, we have a j. So this is minus j. In place of j to the exponent of 5, the answer is the same in simplest form as a j. This is what we are used to. So instead of having these exponents of 5 that we do not understand, let's simplify to the simplest form. This, we are used to this. So from this, how can we simplify further? What does it mean, this part? All right. Remember the issue of a j, that it's actually representing a square root of minus 1. So if you take this, it's like you are in seds, where you've got minus square root of minus 1 plus 1 over minus 1 minus square root of minus 1, where you're dealing with set. What do you think of rationalizing the denominator so that we do not have the square root? In the same manner, we must make this denominator to be a rational term. A rational term. So it's up to you whether you want to get rid of this negative that you are seeing here. Guys, this is mathematics. Mathematics is it's the way that you actually understand. You can play around the way that you want. You can work as it is with the minus. What is important is that whenever you're rationalizing, you must introduce a negative on j. So introducing a negative, that will be minus 1 plus a j over what? Minus 1 plus aj. So that is the product of these two will give us a rational term. So as you can see, this is just a product that we are given on top. The j minus 1, which is same, the minus 1 minus j plus 1, and you've got minus 1 plus j. It's a product of the two. It's a product. So you can even expand because the product, these two are multiplying each other. That is minus j plus 1 into minus 1 plus j. Everything over minus 1 minus j into minus 1 plus j. You can expand your brackets. Minus j is to multiply everything in the second bracket. So that's minus j times minus 1. Minus, that's a positive j. Minus j times a positive, this is a positive j. So it will be minus j squared. We are done with the minus j. Moving on to the positive one, it multiplies everything. Positive 1 times minus 1, that's minus 1. Positive 1 times j, that's a positive j. Same sense in the denominator. If you were to expand your brackets, minus 1 multiplies everything in the second bracket. Minus 1 times minus 1, that's a positive 1. Minus 1 and j, that's minus j. Get done. We move on to minus j. It does the same, multiplies the second bracket. So it's minus j times a negative 1. Negative, negative, that's a positive j. Minus j and a positive j, that will be minus j squared. All right. Understanding that j squared is equal to minus 1. Thus, wherever there is a j squared, we are going to substitute with a minus 1. Because we understand that j squared is minus 1. So there we have got a j squared. There we have got a j squared. So meaning to say we are going to have a negative 1. A negative 1. Okay. So let's simplify j plus j. That is 2j. This is the same as 1, 1. 1j plus 1j. That is going to be 2j or j2. Remember, I said j squared is minus 1. So there is a minus already that you are given. Minus 1 and a minus 1, that will be a positive 1. Minus this 1 that you are given. So that's a 0. It cancels. So this was going to cancel. That's a 0 because it was going to give us a positive 1. All right. Minus j plus j cancels. You are left with 1 minus the j squared, which gave us a minus 1. So minus, that's what? A positive. So that's 1 plus 1, which is a 2. So this was going to give us a 2. And this can cancel. You are obtaining a j at the end. We could have simplified that direct from the original. If you just understand your exponents here, you can actually expand. Guys, if let's say you understand your exponents, you could have just expanded direct. J to the exponent of 3 plus j to the exponent of 4 over j squared minus j to the exponent of 5. The concept is still the same. The negative, I affected, so I'm going to multiply. This changes to a positive. So that will be j squared plus j to the exponent of 5. And this will be j squared plus j to the exponent of 5. As long you understand your your complex numbers at the end, like how to simplify them. The product of the two in the numerator, that is j to the exponent of 3 plus j to the exponent of 4 into the bracket of j squared plus j to the exponent of 5. Then the denominator, as we can see, that is j squared minus j to the exponent of 5 into j to the exponent of 2 plus j to the exponent of 5. Okay, so let's see what were we supposed to have at the end from this. Product multiplies everything in the second bracket. So remember the concept of the product. Now, exponents, if you're multiplying the bases which are the same, you add the exponents. So the j to the exponent of 3 times j to the exponent of 2, you add the exponents 3 plus 2. That is j to the exponent of 5. If you multiply to the exponent of this, so 3 plus 5, that is j to the exponent of 8. Okay, you are done with the j to the exponent of 3. J to the exponent of 4 multiplies j to the exponent of 2. So you add the exponents. So 4 plus 2, that's to the exponent of 6. J to the exponent of 4 and j to the exponent of 9, that will be 4 plus this, that will be a 9. I mean, 4 and 5, that will give us a 9 if we add. The denominator, still one and the same thing. Expand the second bracket from the first bracket, so that's j squared, and j squared, you add the exponents. 2 plus 2, that's a 4. J squared and j to the exponent of 5, you add exponents. 2 plus 5, that's a 7. There we've got a minus, but still the bases are the same. So that's 5 plus 2, which is a 7. And this, the product, again, you add, but that's a minus. J to the exponent of 5 plus 5, which is a 10. Add exponents. If you understand it that way, that is what you're going to do. But as you can see, the only part that you can simplify is this j to the exponent of 7 minus j to the x. These two are the same. We can properly see that they are the same. We do not need to simplify. You can actually cancel these two. But the rest, what are you going to do? You are still going to need that simplification later on. So you could have used it in the first place, or you simplify up to this stage. Then you now go back to that simplification. What does it mean? J to the exponent of 5, j to the exponent of 8. We are back to that part again, you see. So there is no way that you're going to escape that. So we simplified j to the exponent of 5. Remember, in the last part, we got a j. So this is going to give us a j. That is in place of j to the exponent of 5. J to the exponent of 8 is same as j to the exponent of 4 to the exponent of 2. Remember, we simplified j to the exponent of 4. This one, it gave us a 1. So it's 1 to the exponent of 2, which is a 1. So this one is still a 1. J to the exponent of 8 is same as 1. J to the exponent of 6, we can simplify. If we simplify j to the exponent of 3 before, j to the exponent of 3 before, we simplified, remember, j to the exponent of 3, when we simplify this, it gave us a minus j. So if j to the exponent of 3 gave us a minus j, j to the exponent of 6 is same as j to the exponent of 3 to the exponent of 2. So it's minus j squared. So that means minus j squared means minus squared. That's a positive j squared, a positive j squared. But j squared is minus, so it's a positive times minus 1, which you end up with a minus 1 at the end. So this is a minus 1. J to the exponent of 9 is same as j to the exponent of 8 times a j. We simplified j to the exponent of 8. It gave us a 1. Okay, that's j to the x times a j. Why am I saying plus? Times. So that's j to the exponent of 8 is a 1 times a j. That is going to give us a j. So that's a j in simplest form. J to the exponent of 4, remember we said it's a 1. What about, we're going to subtract here, j to the exponent of a 10. So this is minus j to the exponent of a 10. So we can take j to the exponent of 10 from j to the exponent of f5 squared. So what is j to the exponent of 5? We simplified j to the exponent of 5 before. All right, this is j to the exponent of 5 is equal to what? It is equal to j. So if j to the exponent of 5 is equal to j, it means we have got j squared, because there's a squared here. And j squared is equal to what? -1. So it means j to the exponent of 10 is -1. So that's a minus and a minus that we are going to have, which is a plus. All right, so let's simplify. 1 minus 1, that was going to be a 0 there. We are left with the j plus j, that's 1j plus 1j, which is going to be 2j over minus and minus, that's a plus, so that'll be a 2. This cancels, so that was going to give us a j. Guys, this is mathematics. The beauty part of maths is that you can work it the way that you feel like, as long it is applicable, as long it is applicable. So let me know any other alternative that you could have used to simplify this. So is it, or which one do you prefer? If there is any other way, let me know so that we can also try and work with that other way in another part. We were given solve for m and n from these two equations. That is 2.5. We are given m plus n plus a j into m minus n is equal to 7 plus 2j. Solve, it means that's an equation. You must have the value of m and the value of n. So what was the idea of this question? These are complex. Remember, from your rectangular format, it follows that there is no way that you can write a plus b j to be equal to x plus, let's say, y j like this. Okay, let me start with the j so that you understand, because if I write this way, maybe you might not understand me. jb is equal to that x plus jy like this. So maybe if I start with a j, you can understand. There is no way that these two being in the same format, rectangular format, and we are saying they are equal. What does it mean? It follows that this and this must be equal, which are the real terms. The real terms is any part where we do not have the j. Remember, j is imaginary. J is equal to square root of -1. That's an imaginary value. So the part of j, meaning to say the part of jb must be equal to the part of jy, the imaginary. So this was a straightforward, because we can see it that the first part of m plus n, it's real. We do not have a j. On the second equation, on 7, we do not also have a j. So these two, they must be equal. They must be equal. You take the part of j, like I say, the part of j is supposed to be, meaning to say this part with the j, that is plus j into m minus n is equal to the part of j here, which is plus 2j. But as you can see, guys, the plus j, this plus is the same. So it simply means m minus n is equal to 2. That is what it simply means. You can just take it straight. M minus n, because this part is positive, this part is also positive. So m minus n is equal to what? Is equal to 2. This is what our rectangular form is giving us. That is what we are having. From this is no longer complex numbers. These are now your normal equation. What type of an equation have you formulated after that? These are simultaneous equations. You can solve the way that you want, elimination method, substitution method. So we are very much used to the substitution method. So this time I'm not going to use substitution method, but I want you to use substitution method as a way to prove if you're having the same answers. In this case, I'm going to use elimination method. I'm going to eliminate, let me eliminate m. So I'm going to eliminate m. So to eliminate m is a positive, it's a positive. So I can subtract equation 2 from equation 1. This is our equation 1. This is our equation 2. So what I'm simply trying to say is I'm going to subtract equation 1 minus equation 2. Okay, this is to eliminate m. So if I subtract, it is going to be m minus m, that's a 0. M is eliminated. All right. Then n minus n is n minus n. So it's going to be a positive. So that will be 2n is equal to 7 minus 2. 7 minus 2, that is going to be a 5. So we can determine the value of n by dividing. That's n is equal to 5 over 2. So having the value of n, I can even eliminate n, then solve for m if I want, or I can just substitute the n that I'm having in n of the equation. In place of n, it means m plus 5 over 2 is equal to 7. I can substitute in any equation. I can substitute in the second equation. So transpose to the other side, m is equal to 7 minus 5 over 2. So that will be our m. So at the end, our m was going to be equal to 9 over 2. So like I said, I want you to use the substitution method, the one that you are used to, and see if you're going to have the same values of m and n. So that is our complex numbers. I don't see anything challenging, guys. Let's revise more questions. Like I said, if there are any questions that you feel like, okay, let's work on this part. Let it be so. Let us work on that part together, revise on that part together so that you're able to understand the concept. All right, question number 3, you were given first part, it was to prove. In most cases, like I said, the proof is a simplified question. This is a question that was supposed to be a simplified question. In a normal sense, when you are given it, it was supposed to be simplified. All right, so that's question 3.1. We are given to prove that 2 sine cubed x plus sine 2x, all right, times cos x, the product of this, okay, everything divided to 2 cos x. This is equal to the tan of x. 5 marks. Okay, let's see. Remember, this is a proof. You are given the answer already. So choosing the left-hand side, which is the most complicated part, it was going to be the best. So working from the left-hand side, where we are given the 2 sine cubed x plus the sine of 2x times the cos of x, everything over 2 cos x. How can we obtain a tan? Okay, let's think of this. It's a stage by stage. Do we have any identities here so far? There is an identity. Remember, this is a double angle. The sine of 2x is equal to the 2 sine x cos x. There's just one identity there. Just one. So let's write and see. 2 sine cubed x plus the sine of x, which is the product of this. 2 sine x. So let's see. It's going to be 2 sine x cos x. We have substituted the sine 2x. But there is also a cos x, which is already part of the question, this one. So already there's a cos x there. Everything over what? 2 cos x. Okay. So this is where we are now. In a normal sense, you think of, let's say, to divide, because That's a single term. That's what we're having here. Remember, A plus B over C is equal to A over C plus B over C. So we can separate this. Guys, this is to prove you do not even know like what is going to happen, but the simplifications as you are moving, they are supposed to be like you're in the right direction. Okay, so if we had to separate, that was going to be the 2 sine cubed versus the cos of x. So that is 2 sine cubed x over 2 cos x plus the remaining part, which is the 2 sine x cos x. So it's actually a cos squared now. It's actually a cos squared, but you can actually write this like it's a cos squared that we are having here. So we are having a cos squared x, cos times cos, everything over 2 cos x. All right, there's something here that I want us to be clear. At this stage, that is, most of us, we got to this stage, but there, I don't know which method did you use. If you use it this way, you got to this stage, then you are stuck to say, what can I do at this stage? Okay, I want you to see, your answer is supposed to be a tan. This is your answer. You're supposed to obtain a tan. They wanted to trick you guys here. I want you to see something. Already here, I'm having a tan. Sine over cos, it's a tan there. Okay? Meaning to say I can also obtain a sine over from sine cubed here, because there are 3 sines here. I can just take one. Remember, sine over cos is a tan. So here the tricky part was when you cancel now here the cos, because you are tempted to say this is cos and this is cos, you cancel. It was a temptation that you're given there. That was a temptation. That was a temptation. Focus with what you need to obtain a tan. So focus with sine x over cos x. Do not cancel the cos because you need it to form a tan. So on this side, it's sine cubed. Okay, let's cancel the 2 and the 2. This one, it's sine cubed. Sine cubed means there are 3. It means sine cubed, it's like this. It means sine x times sine squared x over a cos. What we just need is to focus with a sine. We need a sine over a cos, so that a sine over a cos, this one, it gives us what? A tan. So there is a tan x times what? Because this gave us a tan, this one. This is the tan. But what is remaining? There is a sine squared remaining. So this gave us a tan. Sine x times the sine squared. It's still the sine cubed. But as we want to separate the sine over cos, this is what we want. The sine over cos is what we want. So we are remaining with the sine squared x. Take note, they wanted you to be tempted. Plus, we move on to the same situation on this plus of the other part of the simplification. We still need the tan. So do not cancel the cos and the cos. The moment you cancel the cos, you have the tan is no longer there. You want to have a tan. Tan is obtained from what? Sine over cos. You can see it. It's there, this one. So this sine over cos, it is going to give us what? A tan. That's tan x. So we have simplified this. It gave you a tan. So what are you remaining with? You are remaining with a cos squared. So it's going to be times cos squared x. They wanted you to be tempted there. Sine, tan. Okay? So once we're at this stage, I think now you can even conclude we are done, because tan and tan is common. So you can factor out the tan of x. What are we going to remain with if we factor out tan x here? We remain with a sine squared. That's a sine squared x. If you factor out a tan x here, what are you going to remain with? A cos squared. So that's a cos squared x. Knowing that sine squared plus cos squared is equal to 1. That is the first Pythagorean identity. This is the first part that you're supposed to understand in your identities. So that's times 1, which is the tan of x. So as you can see, this is exactly equal to what we had on the right-hand side, which is the tan of x, the tan of x. So this is the product. Tan x times 1, that's the tan of x. This is equal to 1. So you see how they are testing you guys. They know you are now used to these prove. Try to dig deep. That is into your identities. Just try to work more. So we're gonna try also to add more of our identities. I just hope, guys, you see the issue of time, more work, this and that. But if we have time, we're gonna try to explain more on our identities, but just also watch the trigonometry videos that we have. They can actually help you some more to attempt these typical questions. So like I said, this question could have been simplified, but instead they're asking to prove. All right, let's check what we are given. That was 3.1, 5 marks for that. 3.2 again. So this one was a simplify. Now it's no longer to prove, but it's simplify this. So this time it is the same thing. They were supposed even to ask you prove that this is going to give you this, but it was just to simplify. All right, so let's see. 3.2, 5 marks again. So 3.2, we are given to simplify the following expression. That was the sine of 180 degrees minus theta times the tan of 180 degrees plus theta again times the cos of theta plus 360 degrees. All right, then we were given divided to the cos of 90 degrees minus theta times the cos of minus theta times the tan of 360 degrees minus theta, like this. This is what I want you to understand. Actually, this one, it's a direct question because you just need your angles, the quadrants. Remember your relationship in the reduction of your angles from positive and negative angles. This one, we talked about it on the trigonometry. Check the video. So I said in terms of your quadrants, remember the first quadrant, you just talk about the theta. And in that case, every part is going to remain as it is. With the sine of theta, the cos of theta, everything as it is. In the second quadrant, that's where you've got 180 degrees minus theta. This is 180 degrees plus theta. This is 360 degrees minus theta. These are positive angles. Remember, as we take in an anti-clockwise direction, we talk about positive angles. In the other way, we are going to talk of negative angles, where we talk of this angle being minus theta, this angle in this quadrant being minus theta plus that is theta minus 180. All right, that is the part of theta minus 180 degrees. From the concept, it was supposed to be 180, theta minus 180. You multiply it by negative, so it will be 180 minus theta. In this part, instead of you to be having 180 plus theta, you multiply by a negative, so it will be 180 plus theta with a negative. Instead of you having 360 degrees minus theta, you're going to have theta minus 360 degrees. These are negative angles. So the concept is, do you understand? So just go through that video again, or trigonometry. So as you can see, also considering the cast concept to conclude, the sine 180 minus theta. 180 minus theta is in the second quadrant, and that is the quadrant of a sine. So sine is positive there, times tan 180 plus theta. 180 plus theta, that is the quadrant of a tan in the third quadrant, and tan is positive there. So that is the tan of theta times cos theta plus 360. Theta plus 360 is you have completed 360 is a complete revolution. So it goes back to the first quadrant where it will be a positive. So that will be cos theta. All right, then we have got 90 minus theta, the cos of 90 minus theta. This is the relationship that we have between a cos and a sine. All right, remember from our supplement, the supplementary concept of our angles. This is equivalent to the sine. If it is the sine of theta, it is equal to the cos of 90 degrees minus theta. If it is the cos of theta like this, it is equal to the sine 90 degrees minus theta. So there we are given cos 90 minus theta. So cos 90 is a sine. So that is, we have got a sine of theta. Cos minus theta is in the fourth quadrant. That's a negative angle. This angle minus theta, it is the same as cos 360 minus theta. 360 minus theta is a positive angle. It represents a positive angle. Minus theta, it represents a negative angle. I talked about the difference between these negative, positive angles. But since they are in the quadrant of cos, the C, cos there is a positive. So it is going to be positive cos. The angle is negative, yes, but the cos, as you simplify it, it is going to be a positive value. Take note about that, okay? Then tan 360 minus theta, 360 minus, it's a positive, 360 degrees minus theta, it's a positive angle, this one. But this quadrant is not of a tan, is the quadrant of a cos. Tan there is a negative. So it means it will be minus tan theta. Tan in this quadrant is a negative. The angle, it's a positive angle. Yes, it's a positive angle, but the tan in this quadrant is a negative. So do not confuse when I'm talking about positive angles and the positive of a trig. The positive of a trig is the one that you use because of this quadrant to say is the quadrant of a cos, the quadrant of a tan, the quadrant of a sine. Being positive of angles is something else. Like I said, please guys, let's go through our trigonometry video so that we can understand much about this. All right, so there we are going to cancel. Remember, it's a product, so you can cancel wherever it's applicable, the tan and the tan. So you're going to obtain a -1. So this is just like we've got 1 over -1, which is -1 at the end. So this whole part, after simplifying, it was going to give us a -1. All right, so that was it for 5 marks. Evaluate the following without using a calculator. 5 marks again, 1 over the sec of 105. Okay, why 5 marks? Let's see. Without using the calculator, without the use of a calculator, sec 105 degrees. What is the sec? The sec, where is it taken from? Remember, 1 over cos theta is the sec of theta. So it's the opposite way now. 1 over the sec of theta, it is equal to the cos of theta. So whenever you are given the sec, it is just like you're given a cos. 1 over a sec, it's a cos. So this was cos 105. So the question, instead of asking you to simplify cos 105 without using a calculator, because they know you are now used to these questions, they just want you to be confused now. Look how they're asking it. But we know how to simplify this. In the same manner, they are going to ask you the same question. Simplify 1 over cosec 105 degrees without using a calculator. If you know that 1 over sine of theta gives you a cosec of theta, so it means also 1 over a cosec, it's a sine. So instead, the question of asking you, simplify sine 105. Look how they are trying to ask, they try to confuse you because you are used to these typical questions. Remember your double angle identities. Your double angle identities from the identity of a cos. The cos of A plus or minus B is equal to the cos of A, the cos of B, the sign changes, minus, plus, the sine of A, the sine of B, provided that addition or subtraction. So you can separate 105. Since the calculator is not required, we must express it in terms of the special angles now. Those 45 degrees, those 30 degrees, 60 degrees, 90 degrees. Are we having a combination of two angles that we can add or subtract? Then you obtain 105. If you add 60 degrees and 45 degrees, that's 105. And these are special angles. So it is just like you are given cos A plus B. If it is a plus, if it is cos A plus B like this, it is going to be cos A, cos B, minus sine A, sine B. So it means this is going to be cos A, which is cos 60 degrees, cos 45 degrees, minus sine A, sine B, which is the sine of 60 degrees, the sine of 45 degrees. Guys, at this stage, this is where I said the application of the special angles is the one that we use. At this stage, you can even use your calculator. It's not even, they are not going to even know that you have used a calculator or not. Guys, these cos 60, cos 45, sin 60, someone knows these values by head. They don't need those triangles to, okay, this is where, these are values that you're even supposed to know by head. That's why you call them special angles. Also, know them by head, you know them by calculus. So you can even if you do not know that, you go back to those triangles or you just use a calculator. But from our triangles, the cos of 60, that's 1/2. The cos of 45, it was supposed to be 1 over square root of 2. But 1 over square root of 2 is same as square root of 2 over 2. Minus the sine of 60, which is the square root of 3 over 2. The sine of 45, the square root of 2 over 2. So that is, at that case, guys, even if you are saying do not use a calculator, there you can even just use, even here you can just even use a calculator. The simplification there later on, as long you are showing stage by stage, do not just simplify everything at once. 1 times square root of 2, that is square root of 2 over 2 times 2, which is 4. Square root of 3 times square root of 2, that is square root of 6 over 4. You cannot lose marks because you're asked not to use a calculator, and you can't use a calculator to multiply square root of 3 times square root of 2. If you do not know this, multiply direct on your calculator. Okay? The denominators are the same. So how are you going to simplify? You simply subtract the numerators together. Square root of 2 minus the square root of 3. Everything over what? Over 4. It is because the denominators are the same. So we can simply combine our numerators together. So when the calculator is do not use a calculator, they are saying at this stage, do not just take your calculator. 1 over the sec is same as 1 over the cost of this. Then it gives us the cost of 105. You just take your calculator simply. No, not like that. But along the simplification, guys, never be limited in exam. Never be limited to such an extent that you can lose marks because you'll be saying, I'm now using a calculator. They are saying, do not. No, these ones, use a calculator at this stage. It's not even a problem at all. All right, so that was 3.3. let us see what we are given on 3.4, which is the last part of question 3 on our trigonometry. Determine the value of, okay, there's no, like, how? Guys, how is that? So we do not have a trigonometric equation. Okay, anyways, it was like that. Anyways, it was like that. It was fine. But I'm just surprised, like, okay, so I was hoping for a trigonometric equation. They would determine the value of, it was 1/2 into the cos of 15 degrees plus the square root of 3, the sine of 15 degrees. Determine the value of, guys, you are not given instruction, do not use a calculator. No, you are not given that instruction. So whether you wanted to simplify back to say this side, I mean the cos of 15 degrees, it is the same or as cos 45 degrees minus 30 degrees. Guys, it was gonna be in your hands. You can just use a calculator. Simplify this. This is gonna be cos 45, cos 30 degrees. Remember, cos, it's a minus, so it's add. So it's gonna be sine 45 degrees, sine 30 degrees. You do the same thing, you simplify like what we did on the other part. You do the same thing even for the sine of 15 degrees. It is gonna be the same as sine 45 minus 15. Sine 45 degrees, minus 30 degrees. But for sine is different. Remember, sine is sine cos. Sine 45 degrees, cos 30 degrees. It maintains the minus as it is. Then it will be sine 30 degrees this time. Then the cos of 45 degrees. Guys, it was going to be up to you. Simplify everything up to the end. So I want you to use this because we talked about this, guys. So you're going to see that on this course, you are going to obtain later on the square root of 6 plus the square root of 2, everything over 4, plus the square root of 3 times the sine of 15 from that calculation. You are going to obtain the square root of 6 minus the square root of 2 over 4. So I just want you to challenge yourself. We talked about that on that part of course 105. Just try to see if you are in the on the right page. All right. So from here, you can now simplify further. You simplified these, guys. You got your answers there. You simplified, evaluated, then you substitute. Every calculation is supposed to be shown. All right. Can we simplify this part? Yes, we can. If you're to consider there's a square root of 3, that is to multiply everything. So let's just see. The denominators are the same. So we can just write as over 4. Then this is the square root of 6 plus the square root of 2. But the square root of 3 is affecting this part. Square root of 6 minus square root of what? Square root of the square root of 6 minus square root of 2. So it's the square root of 3 times the square root of 6, which was going to be the square root of 18. And the square root of 18 is 3 square root of 2. This you can just press on your calculator, guys. There's no need for you to show anything there. So that was going to be 3 square root of 2. The square root of 3 times the square root of minus 2, that is the minus square root of 2, that is square root of 6. So it was going to be minus square root of 6. So as we can see, we have got like terms here. Square root of 6 and square root of 6 can cancel. Square root of 2 and square root of 2, we can add our like terms. So that's 1/2. We add the like terms. So that's 1 plus 3, which is 4, square root of 2 over 4. So that was going to give us something like this. This can cancel. So you're left with 1 over 2 times the square root of 2. So that will be square root of 2 over 2 at the end. So that is what you're supposed to have simplified from what you're given. As you can see, stage by stage, your simplifications, take them stage by stage, simplify everything stage by stage. With this, you substitute, like I said, on this substitution, even if you do not understand the triangles, just use a calculator, the square root of 2 over 2, the sine, the cos of 30, everything substitute. Everything you substitute direct. So the cos of 30 is supposed to be just like the sine of 60. Remember, cos 30 and sine 60 are the same. So it is square root of 3 plus this one, square root of 2 over 2, sine 30. It's 1 over 2. All right, you multiply this, that will be square root of 6 over 2 times 2, which is 4. Square root of 2 over 2 times 2, which is 4. This is what I'm trying to say. So let's try, guys. Simplify also. You're going to have the same answer on this one. So I want you to just try to do it and see if you be we are on the same page actually. So that was our question 3, 20 marks on everything on the trigonometry. So as you can see, it's no longer like it's just mixed. It was a mixed type of a question paper that we had. Remember, we just used to that part of 2020 question 1, 2020. It can be like this. It can be like this. So as you can see, the question 4 was 25 marks, and also question 5, which is the question 5 on integration, 25 marks. So now we can see integration is having 25 marks. The derivative was 25 marks. It was having 25 marks, the part of the derivatives. Let's revise, guys. If it is like this, it's a lot of marks that you are having there. A lot of marks, 25 and 25, you are at 50%. If you can collect those 25, 25, you are already at 50%. So let's see how we're supposed to have attempted the first part. So if you're to check them, you were given to expand this x minus 2 to exponent of 5, but to 4 terms. Take note, up to 4 terms. So let's just see how you're supposed to have expanded this part. So that is 4.1, where you are given x minus 2 to the exponent of a 5. Then you are given up to 4 terms. So remember from the binomial expansion that we had that we can expand exponents that are greater than 3 and so on. If we're working with a 3, yes, we can use it, but it is not necessary for a 3, talking of 4, 5, and so on. These exponents or negative exponents, or those exponents that are having fractions, these exponents, we can expand them using the binomial expansion, which, if you do understand your formula, it's fine. If you do understand your formula, if you're given x plus h, or maybe x plus a to the exponent of n, is going to be x to the exponent of n plus n x to the exponent of minus 1, n minus 1 times a, everything over 1 factorial, plus n times n minus 1, x to the exponent of n minus 2, a to the exponent of 2 over 2 factorial, and so on and so on and so on. So what does it mean? If you check the part of n, I simply explained as the derivative. You see, this is the derivative concept. You are simply differentiating the part of x. Then what is happening with a? We are having a to the exponent of 0, a to the exponent of 1, a to the exponent, a is increasing, which is if you are given in this format. If you are given in this format. So this is the same as we are given x plus a minus 2 like this. That is to the exponent of a 5. So that you can properly see that this is representing x and this is representing your a. So meaning to say from this expansion, we're going to have x to the exponent of n to the exponent of the power that you're given there, which is 5. Whereas the minus 2 is raised to the exponent. So this one is just like minus 2 to the exponent, so it does not affect. Remember, any number to the power of 0, that's a 1. So this part, you can even leave it like that. Anyways, let us move on to the next term. So if you do not understand, like I said, just take the derivative, the part of x, just differentiate. Wherever you see x, differentiate on the next term. So you differentiate this. So differentiating x to the power of 5, you obtain 5x to the power of 4. Remember, you drop the exponent, you subtract 1. That is the concept. Whereas the minus 2 is increasing its powers. Minus 2 to the power of 1 over 1 factorial. Plus, we move on to the other term. The part of x differentiate. So 4 times 5, that is going to be 20. You subtract 1 on the exponent, that's going to be 4 minus 1, which is 3. Just differentiate this part, the way that you differentiate your normal terms. Minus 2 is increasing to the exponent of 2 over 2 factorial. How many terms? 1, 2, 3. Still there. The last term, we differentiate the part of x. So if you differentiate 3 times 20, that is 60. You subtract 1 on the exponent, that is 60x squared. Minus 2 is increasing its powers to the power of 3 over 3 factorial, and so on and so on. So this is what you're supposed to have. Okay, so as you can see, this is just a 1. 1 times x to the power of 5, that is x to the power of 5. So make sure that you simplify properly on your calculator. This times this over 1 factorial. If you simplify, that was going to give us minus 10. So we've got minus 10x to the power of 4. Simplify also my 20 times this over 2 factorial. You are going to obtain 40x to the exponent of 3. 60 times minus 2 to the power of 3 divided to 3 factorial. You are going to obtain minus 80x to the power of 2, and so on. So this is what you're supposed to obtain at the end. So that was a little bit direct question. All right, then 4.2, that was to determine, given the limit t to the exponent of 3 minus 8 over t to the exponent of 3 minus 8 over t minus 2. This is as t is approaching to 2. All right, as t is approaching to 2. How can we simplify this? The limit as t is approaching to 2, then we are given t to the exponent of 3 minus 8 over t minus 2. This is what we have. Okay, if we're to substitute this t, which is 2, in place of the t, that was going to be 2 to the exponent of 3 minus 8 over 2 minus 2. That's a 0 over a 0. Remember, this does not exist or cannot be simplified. Wherever you are given this, think of a condition where you can get rid of the denominator. Can the numerator be factorized so that we get rid of the denominator? Can we separate each term? In this case, we can factorize the numerator. That is a cubic expression that we are given there. T to the exponent of 3 minus 8 is same as 2 to the exponent of 3. 8 is same as 2 to the exponent of 3. Why am I referring to this part? This t and the 2 raised to the exponent of 3 can be factorized. Remember, when dealing with the cubic terms, the sum and the difference of 2 cubes can be factorized. When dealing with a perfect square, we just know of a difference of 2 squares. But dealing with cubes, there is sum and difference of 2 cubes. X to the exponent of 3 minus a to the exponent of 3 can be factorized as x minus a, the first minus the last term, into the first squared plus the product of the first and the last together, which is ax plus the last squared. If it was a plus here, it means this will be a plus and this will be a minus. That is the only part that is affected. So using this identity, you can factorize this because there, this is the first term, second term raised to the exponent of 3. So it's going to be first minus the last term into the first term x squared, which is t squared, plus ax, which is the product of the first and the last, 2 times t, which is t times 2, which is same as 2t, plus a squared, which is the last term squared, which is 2 squared, and 2 squared is 4, 2 to the power of 2. That is the idea there. So meaning to say we could have factorized, we can factorize this actually. This was going to be given as the limit as t approaches to 2 of, we consider the part that we are given, which is the t cubed minus 8. This is what we obtained. That is t minus 2 into the bracket of t squared plus 2t plus 4. Everything over what? Over t minus 2. So you can even write in a bracket like this. Just ignore the bracket, does not affect anything. With the limits that we are given, if we are to substitute here, we are going to have the same thing unless we get rid of the t minus 2. As we can see, it is the same as the t minus 2 in the numerator. So these two can cancel. And you are remaining with the limit as t is approaching to 2 of what? There is t squared plus 2t plus 4. That is what we have. As t is approaching to 2, you can substitute wherever you are given the t. We no longer have the denominator which was affecting. So in place of 2, in place of t, we are going to substitute a 2. So that is, we are going to have 2 to the exponent of 2 plus 2 times 2 plus 4. You are substituting the limit, so you're no longer writing this limit. So that was going to give us a 12 at the end. That is 4 plus 4 plus 4. Just like that. So questions can be on limits, can be the derivatives. As we can see, 4.3, it was a derivative. Differentiate the square root of cosec x using function of a function, which is the chain rule. How can we differentiate the square root of the cosec of x using the function of a function? The square root of cosec x, we understand it is the same as the cosec of x being raised to the power of 2. So we can actually understand that the function of a function can operate there because we do understand that it is a condition where we are going to use the formula, the derivative of y with respect to x is equal to dy du times the derivative of u with respect to x. This is the formula of a function. But from where? Introducing a function in place of another function. This is the function that we have, which is cosec. So we can let u to be equal to the cosec of x. By letting u to be equal to the cosec of x, therefore, we are going to see that y is going to be written as, in place of the cosec x, we said let it be represented with u. So it is going to be u to the exponent of a half. The cosec of x, it is now represented with u. So as you can see from the formula, we need the derivative of u of y with respect to u, the derivative of u with respect to x. U with respect to x, y with respect to u. So let us differentiate and see what you're going to have. The derivative of u with respect to x. U with respect to x. Remember the cosec, it's going to give us the minus cosec cot, which we also have from our formula sheet dealing with the derivatives. That is the derivatives y, then the derivative of y with respect to x. So cosec x minus cosec x cot x. So that's minus cosec cot. So meaning to say we are going to have this, all right. Sorry for that. So that is going to be minus cosec x cot x. Okay, so that is the derivative of y with respect to the derivative of u with respect to x. The derivative of y with respect to u is going to give us what? Remember, they're just going to drop the exponent. Then we subtract 1 on the exponent. That's half minus 1, which is minus half. You can even simplify further. This is same as 1 over 2. Remember to get rid of the minus there. So it's going to be 1 over u to the exponent of a half, where we know that u to the exponent of a half is same as the square root of u, or you can just write it as u to the exponent of a half like that, or minus a half. Guys, it's up to you. It's up to you. So this, from the formula that you are given, the derivative of y with respect to x from this formula, that is the derivative of y with respect to u, which is minus cosec x cot x. That is the derivative, of y with respect to u, this one, sorry for that. The derivative of y with respect to u, which is this one that we got here. That is 1 over 2 u to the exponent of a half times the derivative of u with respect to x, which we got the minus cosec x cot x. This is what we have. So you determine your derivatives, then now you can simplify further. Remember, there it is supposed to be the derivative of y with respect to x. Not u, but x. Not u, but x. So this can be written, we can multiply because this is same as over 1. In actual sense, it was supposed to be 1 times this, which is going to be negative the cosec of x times the cot of x, everything over 2 u to the exponent of a half, knowing that the exponent of a half represents the square root. But what is u? Remember, u is the cosec. So meaning to say it is the square root of the cosec of x. That is it, you're done. Substituting the x that we had. In another way, we could have we could have also simplified, because this here, if you're to check, let's say you simplified it this way. If you substituted here, you could have substituted this dy dx was going to be 1 over 2. You remember it's cosec, so it was going to be the cosec of x to the exponent of a half like this. So you see, But instead of having exponent of a half in this manner, just introduce the square root, all right? And those exponents, guys, you can avoid them by the square root. They might not refer it that way, just like they might not talk about that. They might not refer about that in the question, but just try to write your answers in simplest form where it is possible. So that's 4.3. Don't know what you think. If you've got any alternative, let us know. 4.3, differentiate the ln of tan x using the quotient rule over the ln of x. All right, so there's ln tan over the ln of x using the quotient rule. Y is equal to the ln of the tan of x over the ln of x. Remember the quotient rule, you're also given the formula, divide x where you are given quotient rule, it's a fraction. So you're also given this from your formula sheet, all right? So if you consider the part of v, you're gonna have v, then the derivative of u minus u, the derivative of v over v squared, which is in terms of x, you can just write vx, it's fine. The derivative of y with respect, so we're going to need these and substitute. So if you know that you have got challenges of these, just write them aside. U is the numerator that you're given here. So you know that u is equal to the ln tan of x. So let's differentiate this u. The derivative of u is what? Remember the derivative of a ln, if you are given ln f of x, the derivative of ln f of x is equal to the first derivative of f of x over f of x. Just like you are given the derivative of ln x. How do you differentiate ln x? Is the derivative of f of x. The derivative of x is 1 over that f of x, which is over x. So you just used 1 over x, 1 over, no, it's first derivative over f of x. There is somewhere which is it is taken from. So meaning to say the derivative of a ln f of x, our f of x is the tan. This is our f of x. So it is going to be the first derivative of a tan. The derivative of a tan, it is what? That is the question. If you differentiate a tan, so we need the derivative of a tan. Okay, so guys, know your derivatives also. Just gonna go through your formula sheet, but the derivative of a tan is sec squared. All right, let me just hope it's not gonna affect us. So that's a sec squared. So that was going to be sec squared, derivative of a tan. So you've got sec squared x over what? The f of x, and the f of x is the tan of x. Okay, so in the same manner, we were given the ln, but for ln, guys, we are used this one. We just used v is equal to the ln of x. So what is the derivative of v with respect to x? That is 1 over x. That is the one that you just write 1 over x. But we're using that same formula. All right, let's substitute v according to the formula. V is the denominator, which is the ln of x. So that's ln x times the first derivative of u, which we got the sec squared x over the tan of x minus u. Remember, u is the numerator, which is the ln tan of x. Okay, times that is the first derivative of v, sorry, the first derivative of v, which is 1 over x. Then everything that we are having here, everything is over v squared, and the v is the ln of x. So this is the ln of x squared. Guys, you can even leave your answer at this stage. It's fine. The simplification there is not even required. You're going to talk about this in our N5, where you just differentiate and leave it like that. use your formula and just leave it like that, okay? If you want, you can simplify further. Guys, it's in your hands. 9 marks to differentiate with respect to y, this part that is given of x in terms of y. So there we are given y to the exponent of 3 over 2. So this one can be differentiated direct. So the derivative of x with respect to y, that is going to drop the exponent. We subtract 1. So that's 3 over 2 y to the exponent. If you subtract 1, that will be a 2. So this one is 3 over 2 y to the exponent of a 2. Okay, that one is direct. The ln of y, just like what you have on x, the derivative of ln of y is going to be 1 over y like this. But there's a minus 2 that is affecting. So you're going to multiply by minus 2. So minus 2 times 1 over y is minus 2 over y. The derivative of a cosec, remember a cosec is minus that cosec, then the cot of y. So it's minus cosec y cot y. Then we have got minus 1 over cot y. All right, let's talk about 1 over cot. Remember, 1 over tan of y gave us a cot. So meaning to say 1 over cot, it's a tan. So this one is simply, we have got minus tan y. So what is the derivative of a tan? That's a sec squared. But already there's a minus, so it was going to be minus sec squared y. So you were supposed to simplify first. 1 over cot, it's a tan. Then the derivative of a tan is sec squared. Okay? 2 pi k. We do not have y in this case. We do not have the part of y there. So this is a constant. The derivative of a constant, that's a 0. Okay? Then we move on to another part where we have got minus 1 over cosec. That's minus 1 over cosec y. Remember, the cosec, we talked about this cosec, 1 over sine, it's a cosec. So 1 over cosec, that's a sine. So there we've got minus sine of y like this. What is the derivative of a sine? It's a cos. But because of the negative, that will be minus cos of y. This is the derivative now. But the first part, it is to simplify this to give us a sine. Then we differentiate a sine, which is a cos. All right. Then we have got 5 over 5 to the exponent of 3. That is 5 to the exponent of 3 y like this over 2. Okay, remember of a constant, guys. You just take the same way how you differentiate a constant. You're given this actually, but this one I talked about this constant concept, the derivative of a constant. This one, ka is gonna be ka to the exponent of x, the ln of a. So if you use this, you're going to see that this is the k. The k is the 1 over 2. But there we have got a constant, which is there is a variable affecting y there. So you differentiate the part of y first. So you're going to find the derivative of y. You multiply to the constant, the derivative of this function of y as it is. Then a to the function of y is going to remain as it is, the ln of what? The ln of a. So meaning to say we need the constant. The constant is the 1 over 2. So that's 1 over 2 times the first derivative of this. The first derivative is 3. A is the 5 to the exponent of 3y as it is times the ln of a, which is the ln of 5. So this one remains as it is. So if you multiply 1 over 2 times 3, that was going to be 3 over 2 times 5 to the exponent of 3y, the ln of 5. Okay? So this is how you're supposed to differentiate. In the same manner with this e that you're given, this is minus 1 over 4, minus 1 over 4. Take the e to the exponent of y on top. It is going to be e to the exponent of minus 9y. So in the same sense, we're going to have this, the constant times the first derivative. So the constant there, that is the minus 1 over 4. The first derivative of y there, that is a minus 9 times a to the, which is the e to the exponent of minus 9y, as it is then the ln of a, which is the ln of e, where we know that the ln of e is 1. So at the end, it was going to be minus 1 over 4 times this minus 9, which is positive 9 over 4, e to the exponent of minus 9y, of which you can even drop this down like this. You can even write it down like this, 9 over 4 e to the exponent of 9y, because it was a negative. You can even write it in the denominator. Remember, the ln of e is equal to 1. That is, you have differentiated each and every term that you're given. The each and every term is supposed to be differentiated. Each and every term. Each and every term supposed to be differentiated. That's 9 marks. Okay, so that was to mark the 25 marks of question number 4. Question number 5, evaluate the integral of these 3 cos 3x with respect to x, where we are given the limits. All right, so let us check. That is 5.1. We are given to integrate 3 cos of 3x, okay, with respect to x. There we are given the limits from 0 to pi. Okay, this is a straightforward integral. Remember, to integrate a cos, if you're integrating a cos, the integral of cos ax with respect to x, it is going to change to a sign, which is going to be sine ax over a plus the constant of integration. So there we've got 3 cos x. So meaning to say, if we had to integrate, this was going to be 3 sine 3x over what? The constant affect the coefficient of x, which is 3. But we have got the limits now, pi and 0. So we have to consider our limits. These two numbers can cancel. So that means we've got sine 3x taken from what? From pi to 0. That's the idea there. Remember I said if you're working with pi, pi means you are in radians. You are going to simplify. Your calculator must be in radians if you're working the pi, unless you have to change the pi to a 180 degrees, all right? But if you're working with the pi as it is, you have to convert your calculator to the radians. So working upper class minus the lower class, which is the lower upper class minus the lower limit that you are given, and our calculator in radians, we are going to obtain a 0 at the end. That's 0 minus 0, which is a 0. If you're using 180, still one at the same thing. It was going to be 3 times 180. So that was going to be a 0 and a 0. So guys, the limits, you integrate straight. Then after that, you apply the limits. I think we talked about these integrals. It's just a matter of more persons to be revised. All right, 6 marks to integrate or to simplify this integral that we are given there. That was 5.2. Let us just see how are you supposed to simplify this 5.2, where you are given to integrate 2 square root of x plus 4x in a bracket. All right, then there we have got the cube root of x minus x to the exponent of minus 1 with respect to x. And in an actual sense, we can see that it's a product of the 2 brackets that we are given. Okay, let's start by simplifying before you integrate. The square root means to the exponent of a half from our exponents. Then the cube root, remember, is to the exponent of 1 over 3. Then already here it's raised to a certain exponent, which is minus 1. Let's expand the brackets. This part multiplies this part. Remember, the product, if the bases are the same, you add the exponents. So 1 over 2 plus 1 over 3, you're going to obtain 5 over 6. Remember, you add the exponent. So that's x to the exponent of 5 over 6 from this part. Same thing, you multiply 2x to the exponent of half to x to the exponent of minus 1. That was going to be a negative 2. You add exponents because you're multiplying the bases which are the same. Half plus minus 1, that's a minus half. So that's x to the exponent of minus half. These are laws of exponents. We are not integrating yet. We haven't started to integrate. We are just simplifying. Move on. 4x does the same, multiplies this first part. So we are going to obtain 4 times 1, which is going to be 4. The part of the exponents, you add the exponents 1 plus 1 over 3. So that's x to the exponent of 4 over 3. Same part, again, 4x to the exponent of 3 multiplies this part. So you're going to multiply 4 times minus 1, which is minus 4x. What about the bases? I mean the powers. Exponents, you add 1 plus minus 1. So if you're going to add, it was going to be x to the exponent of a 0 there, which is what? Which is just minus 4. So this one was just going to be minus 4. That is with respect to x. Now we can integrate. We are used to these. So the first part was to simplify first. Expand brackets. Applying the laws of exponents, you are multiplying the bases, which are the same. You add the exponents. Now we can integrate. So integrating 2x to the exponent of 5 over 6. Remember, the concept is that you're supposed to add exponent. The integral of ax to the exponent of n with respect to x is going to be ax to the exponent of n plus 1 over n plus 1. You're supposed to add 1 on them. On the exponent, 5 over 6 plus 1 is 11 over 6. So that was going to be 11 over 6. You divide by the new exponent that you're given, which is the 11 over 6. So as you can see, these two can be simplified. 2 divided to 11 over 6. That was going to be 12 over 11. So that's 12 over 11. X to the exponent of 11 over 6. Remember, you got 11 over 6. So that's the concept that you're going to use throughout. You add the exponent, you divide. So here we are going to add the exponent 1. You add 1 to the exponent. So it was going to be minus, it was going to be something like this. If you add, it was going to be minus 2x. If you add 1, it was going to be 1 over 2. You divide by the new exponent, which is 1 over 2. Minus 2 divided to this 1 over 2, it was going to give us a minus 4. So that's minus 4, x to the exponent of a half. Okay, the same part with this here, you add a 1 here. So it was going to be 4x to the exponent of 4 over 3 plus 1. That was going to be 7 over 3. So you divide to 7 over 3. So that's 4 divided to 7 over 3, which is 12 over 7. So that's 12 over 7, x to the exponent of 7 over 3. Okay, integrate minus 4x with minus 4 with respect to x. That will be minus 4x plus the constant of what? Integration. That is what we had on this part. That is what we had from our simplification. So these are the typical questions. As you can see, it was actually a question that was given where you need to work each part. Understanding of the question is very, very important. How the questions are given, expansion of brackets, this and that. And then you can integrate after that. All right. 5.31, the sketch the graphs. They were given, sketch the graphs of y is equal to x squared and y is equal to x plus 2. Calculate the points of intersection and show the area to be calculated and the strip to be used. There are two graphs that we are given. The graph of y is equal to x squared and that of y is equal to x plus 2. The graph of y is equal to x squared is a parabola that we are actually used to this being symmetrical to the y-axis. With the y being x squared, it means for the y values, we shall have a positive. I mean, for the x values in the positive, they will be increasing. In the negative also, the y values will be increasing simultaneously. In this symmetrical line of the y-axis that is separated in between, that is, these values and these values are the same, only that the x are positive, these x are negative. Okay, this is a graph that you're supposed to know by head. The graph of y is equal to x squared. If it is y is equal to minus x squared, it will be like this. Okay, so it is just at 0, there is just touches the point, the x-axis at what? At point 0. The graph of y is equal to x plus 2 is a linear function, a straight line, where you need to mark the x-intercept and the y-intercepts. So given that y is equal to x plus 2, the x-intercept is a condition where we do understand that y must be equal to 0. So if y is equal to 0, it means x must be equal to what? Transpose this to the other side, minus 2 is equal to x. For the y-intercept, we are going to have the same condition that x is supposed to be equal to 0. So if x is a 0 here, it means y is going to be a 2. So the most important values that you're supposed to indicate on the sketch for these is the x value at a minus 2 and the y value at a 2. So let's say you were to draw, because as you can see, there's a negative and a positive value. So definitely your line was going to be something like this. Here, I just want to draw, then indicate the points later on. Y is at positive 2 on the y-intercept, and on the x-intercept, x is at what? At minus 2. These are the intercepts of the line, the y-intercept and the x-intercept of the line. Y is equal to x plus 2. So that is how you're going to draw or to sketch these graphs. Then you indicate your representative strip. That is that one that you're going to use to calculate the area enclosed, because you need the limits, and the limits will be the x values. We are going to need the x value here, and also we are going to need the x value at this point. That is why you are given to calculate the points of intersection, which is the point of intersection from this curve, points of intersection. So according to the area bounded, this is the region bounded that we are seeing here, this whole region that we are seeing bounded by the curve. So we need the point of intersection in between the region that is bounded here, which is this point and this point. At these 2 points, how do you determine the point of intersection? Remember that at the point of intersection, the two graphs are equal. The two functions will be equal at the point of intersection. So if y is equal to x squared and y is equal to x plus 2, it means these two are equal. X squared is equal to x plus 2. So you can solve for x. That's x squared transposed to the left-hand side minus x minus 2 is equal to 0. By factorization, we can solve for x. All right, that's x and x here. Remember the factors of -2 or the products of -2, which will add up to a -1. Okay, which will add up to a -1. -2 times 1, that's a -2. If you add, that's a -1. Multiply these two, you obtain a -2. But if you add, you obtain a +1. So this is out, because we need a condition. When we add, we must obtain a -1. So it's from -2 and 1. So that's -2 plus 1. So x will be equal to 2 on the other side, or x will be a -1 on the other side. So these are the values at the point of intersection. And remember that at the point of intersection, the two graphs will be equal. So the first point, from our calculation, where x is 2, you can even substitute where y is equal to x squared. You can substitute where y is equal to x plus 2. When x is equal to 2, y is going to be 4. And another point, when x is -1, you substitute, y is going to be a 1. So that's the point of intersection. So on the graph, there is no need for you to indicate that this is, as we can see that this is the positive side. So 2 is this side. There's no need for you to indicate 2, 4 here, minus, it was the calculate, it was to calculate. So on the graph, you can just indicate the x values, because these are the ones that you use when you are calculating now the area, just to indicate, to say at this point, the x value is 2, and at this point, the x value is -1. Remember, we've got -1, 1, and we've got the point 2, 4 as the points of intersection. Okay? So that was what we are given. And from there, it was now to determine the area bounded by the two graphs in question 5.31 with aid of integration, 5 marks for that. So to determine the area, because we are given two functions here, two graphs, another one covered by another graph. So this time we are not going to use the normal formula that the area with respect to x is the integral of y with respect to x, taking our limits to b. There are two functions involved, so you have to subtract the two functions, but still maintaining the y concept. So it's going to be y1 minus y2 with respect to x. Our limits taken from a to b. So this y1 is the top, the function that you have on the top. Y2 is the one on the bottom. So which one is on the top? It is the line. The parabola is on the bottom according to the region that you are this is the region where you are calculating the area. From this region, you can see the line is on top. The parabola is below. So this means our y1 is the straight line. Our y2 is the parabola. So that is how you're going to have our area. So our area was going to be the integral. The limits, this is the point of intersection. X there is -1, the lower limit. The upper limit at the point of intersection is 2. So y1 minus y2, like I said, the top is the linear function, which is y is equal to x plus 2. So that's x plus 2 minus y2, which is the parabola, and the parabola y is equal to what? Y is equal to x squared. In place of y, we're going to write x squared. With respect to x, we can integrate. So that's our area with respect to x. So we can integrate x, that's x squared over 2. 2 with respect to x, that's 2x. Remember, today we're just gonna, x is just like x to the power of 1. So remember the integral, guys, you add 1, then you divide by the new power, which is 1 plus 1. So that's x squared over 2. There we do not have x. So the answer, we have x. X to the power of 2, you add 1. So that will be minus x to the exponent of 3 over the new exponent, which is 3. With the limits that we are given of 2 and -1, we can determine the area, which is the exact area. We can determine the area, which is the exact area. This is the exact area that we are determining from this integral. So that is in place of x, substituting upper limit, which is 2, wherever there's x. So that's 2 to the exponent of 2 over 2, plus 2 times 2. Place of x, that's 2 to the exponent of 3 over 3. So that's our upper limit, minus the lower limit in place of x, -1 to the exponent of 2 over 2 plus 2 into -1 place of x. That is -1 to the exponent of 3 over 3. So that's the idea there. So this is our upper limit. This is our lower limit. So you're going to simplify this. At the end, you're going to obtain 11 over 2, which is same as 5,5 square units. So that is the area. Integral. Integrals can be used for area. Derivatives can be used for gradient concept. Integrals, area. To calculate the area under the graph. So you were having this already. You know how to apply the limits because you're given a question. Remember how you integrated this. So they can ask you to draw the graph of this within the limits from 0 to whatever pi. Then you ask you to calculate the area. The area that you're supposed to have is the same concept. The integral, but if the area now, you have to consider the idea of the area. All right, integrate or simplify this integral. If you're to check closely on this part, you're given the integral of cos squared plus sine squared. Cos squared plus sine squared is the same as a 1. So this is 1 over sine squared x with respect to x. 1 over sine squared. 1 over sine is what? 1 over the sine of x is the cosec of x. So if this is squared, this will be also squared. So there we are given to integrate a cosec squared x with respect. That is what they are simply asking you guys. And you do not have like that from your formula sheet. So how do you integrate? Because on these integrals that you're given, we are not given a cosec squared. So you go back to the derivatives now and check, is there anything that I differentiated before and got a cosec squared? A cot gave us a minus cosec squared. So if I integrate this, I'm supposed to obtain what is on the other hand. So if I remove this minus on this side, I'm going to put a minus on the other hand. So the integral of a cosec squared, it's a minus cot x. So meaning to say, on that part, we're simply going to obtain a minus cot x plus the constant of integration. We're done. Just like that. So these are the typical exam questions. That was our April exam. I just hope with this, you know where exactly you went wrong or other methods if you got those questions correct. Or just for the preparation sake, maybe you're writing in August, let's revise more questions next time. For those who will be sending the questions, let's just send questions which are clear so that I can work them properly. Let's just send clear questions. We can assist each other as we move on. But for now, that's it, guys. Till we meet again.